Ladies and gentlemen, honorable participants, colleagues, a very good morning to all of you. My name is Aspasia Pastra from the World Maritime University in Sweden. Allow me to take 1 minute to introduce to you our distinguished panelists who will drive us in this journey under the technological advancement pillar. First of all, we have Mr. Stephen Keating, who is an Assistant General Counsel for the US National Geospatial-Intelligence Agency, where he practices international law and fosters international partnership development. From the academic point of view, we have Dr. Tafsir Johansson, who serves as an assistant professor at the World Maritime University in Sweden. We have also industry representatives with us today. We have Mr. Thomas Aschert, who serves as the Marine and Offshore Remote Survey Global Operation Manager at the Lloyd's Leeds Register. We have also, from the industry side, Mr. Yoss Leclerc, who is the president and CEO of the Canadian-based firm Logistro Consulting International. We have also the pleasure to have Mr. Panos Zachariadis, the technical director at the Atlantic Bulk Management here in Greece, and a member of the Greek IMO delegation. And we have also Mr. Gikopoulos, Chief Innovation Officer and Head of Applied Intelligence of Qualco Group. To set the scene for this panel discussion, it goes without saying that our oceans hold 97% of the Earth's water. They provide food and livelihood for approximately 3 billion people. And they act as the world's largest reservoir for carbon dioxide emissions. At the same time, oceans move the cargo through shipping, and shipping carries 90% of all of our cargo. Shipping is also responsible only for 2.9% of the global greenhouse emissions caused by anthropogenic activities. And the IMO, the main regulatory body of the industry, has set strict limits to reduce greenhouse emissions by 50% by 2050. And in this context, all these emerging technologies of robotics and remote surveys, of geospatial intelligence, of autonomous vessels, will make the shipping greener, and we will have the chance to explore more our oceans. So my first question is to all the panelists, and I would like to know if, will you say, that emerging technologies will bring a paradigm shift in your field of specialization. And I will start, Stephen, with you. You have been working with National Geospatial-Intelligence for quite some time. So could you please tell us how intelligent is geospatial intelligence? And please share your experience on that context in the UN Decade of Ocean Science.
Thank you, Aspasia. The answer to that question depends upon the intelligence of the human actors as well as the intelligence or efficiency of the technology we employ. And so we are looking at leveraging machine learning, artificial intelligence developments in the application of geospatial intelligence. And geospatial intelligence is defined in our law as the exploitation and analysis of imagery and geospatial information to define, assess, and visually depict the world, which is physical features as well as human activities that are geospatially referenced. So in the context of the UN Decade for Ocean Science and Sustainability, we have a number of challenges, and one of the challenges is to create a digital model of the ocean. So when we look at this digital model, it's not a static model because the ocean is a complex, dynamic environment that is constantly changing over time. So we have X, Y, Z, and the Z, of course, is the depth. To understand this geospatial model, we are looking at bathymetry, which is the study of ocean depths. So in the context of the ocean decade, we also have a complementary effort called Seabed 2030 and the general bathymetric chart of the oceans. And so the goal of Seabed 2030 is to map the seabed by the year 2030. And the paradigm shift that we are witnessing right now is in the area of crowdsourced bathymetry. And I'll go into that in a later question. Thank you.
Great, thank you. Tafsir, will you say that the same degree of intelligence we find with remote technologies and such as drones and underwater robots in the maritime field?
Well, thank you for the question. With reference to your question, I first take note of the point that full autonomy means highly intelligent, and I wouldn't go as far as to say that the current system bears the hallmark of full autonomy, especially when we consider remote inspection techniques such as aerial drones, underwater remotely operated vehicles, and the likes. And one could easily get entangled in a question of intelligence when we see the news on TV about the National Aeronautic Space Administration sending a drone called Ingenuity on an extraterrestrial voyage to collect data from the surface of Mars. There we see the drone is at play, but what we tend to forget is there is a human base right here on Earth that controls, observes, and monitors every move of that drone. And turning to the maritime domain, I would have to say that things are strictly human dependent. Call it human in the loop, call it human on the loop. Humans like to be in control. And also the level of intelligence that we see in an aerial drone is not the same as an underwater remotely operated vehicle that can or cannot be tethered. Things are very different because they navigate in different environments. But taking together, despite the differences, the current system is not fully autonomous and therefore not highly intelligent. Thank you.
Great, thank you. Thomas, how is the paradigm shift with the classification society since you represent Lloyd's Register?
Thank you for the question, Aspasia. I agree with all of the before mentioned, and I'd like to add that the maritime industry has spent almost $1 billion on artificial intelligence solutions in 2022. It was an estimate that this will double or even reach $3 billion within the next 5 years. While these figures suggest that there has been some significant investment in new maritime application, there should be as well more incentives for making AI certification accessible. And to add to Professor Johansson, next to robots such as autonomous navigation, digital health management, remote diagnostic, and virtual commissioning to transform maritime companies and develop a performance edge. The collaboration and the establishment of digital spin-offs, partner ecosystems, and startup accelerators are key to unlock and explore full potential of these emerging technologies, especially where innovation technology meet complex safety and risk challenges. Thank you.
Great, thank you. Yoss, how different is the paradigm shift when we talk about autonomous vessels, since you have done a lot of work with the IMO working group?
Thank you. Good morning, everyone. First of all, the shipping industry has been and is very resilient. We went from sailing boat to steamers and motor vessels. The first discussion about automation at IMO happened in 1964, and a lot of work has been done towards the mass. And as Dr. Johansson said, I believe that the paradigm shift when we talk about autonomous vessel will be around the human element. As I believe, as Dr. Johansson, that the human element is still and will be in the loop somehow. Thank you.
Thank you. Panos, being also a member of the Greek delegation in IMO, could you tell us about the paradigm shift when it comes to carbon emissions, zero carbon emissions, and all the goals that the IMO wants to fulfill? Are we going there? Are we close to it?
Okay, so of course IMO is the United Nations body that regulates shipping, and the big target that IMO has is to decarbonize shipping. And small bypass to your question, you mentioned in your introduction that shipping emits 2.9% of the man-made CO2. I was surprised to hear yesterday the president of the Union of Greek Ship Owners mentioned a different number. She mentioned 1.9%. So which one is correct? If you go by the computer models, it's 2.7, 2.9. If you go by how much bunkers are sold worldwide, her number is correct. Yeah. And so 1.9 or whatever, 2.7, we need to decarbonize. An IMO target is, of course, for 2030, 40% reduction per transport work, but this is not the difficult target. The difficult target would be an absolute 50%, or now they're going to change it 100% net zero from shipping by 2050 compared to 2008. And for that, we need new technologies and really green fuels, which we don't have right now. Thank you.
Thank you very much. Thank you. And John, please offer us your views about the paradigm shift, how artificial intelligence is bringing this shift in the maritime sector, if it is bringing this.
Well, thank you very much for the question. So I think, again, going back to the facts, so we're talking about a very large sector, so 55,000 vessels, roughly $500 billion in revenues. Out of that, the shipping maritime sector is currently one of the most underpenetrated sectors in terms of technology. That on itself means that there's a huge opportunity to change. There's a huge opportunity to completely differentiate how things are happening right now. We should not forget that out of these 55,000 vessels currently, more than 75% of the global fleet will fail to meet the decarbonization targets that have been set for 2030, let alone 2050. Yeah. Now, out of that, technology can and will change the way things that are happening. Not on its own. Technology is one of the three core levers, so one being hardware differentiation, and the third one being, interestingly enough, slow steaming on its own can have a huge effect. Now, if I were to focus on technology and artificial intelligence as part of that, the ability to, understand and monitor what is happening on a vessel irrespective of where it is, the ability to predictively identify how and where different conditions should be met, the ability to predictively maintain a vessel. This is where artificial intelligence can and will make a difference in the way that things are happening today. We're not there yet, but the technology exists. For us, at least, it's a question of how do we deploy in order to be able to control and adjust.
Thank you. Thank you very much. And I will start my second question. And the technology, yes, is there, as you told, but we are not always there. So let's talk about challenges now. In this for the question and I will do to all the panelists. And some all the critical challenges we have with all these emerging technologies. And I will start with you, Stephen, again. And I was reading a publication, and it impressed me. So for this reason, I want to ask. I take a quote from your publication that more is known about the surfaces of the Moon and Mars than the seafloor. So are the challenges substantial?
Yes, the challenges are substantial. They're not insurmountable. So when we look at the surface of Mars and the Moon, they are far away, but we have been able to successfully remotely sense them, partly due to the fact that they're not covered 70% by water. And that's the problem that we have here. And I remember a comment that Mr. Brooks made yesterday about the challenges of the interface between the air and the water in terms of communicating information. So the challenge we have is both a technological challenge, but then we also have the challenge of policy and how we get better cooperation amongst the nations. So I mentioned crowdsourced bathymetry, and crowdsourced bathymetry is defined by the International Hydrographic Organization as the collection and sharing of data, depth data from vessels using standard nautical instrumentation in routine maritime operations. So we're talking about the type of maritime operations that Panos and Tomas are involved with on a routine basis. These are ships that are transiting back and forth, delivering their cargoes, and they're doing so pursuant to SOLAS requirements to operate an echo sounder. So the challenge we have is to transform what is transient data collection, where that depth measurement is seen and then lost, and to convert that via data loggers to store that data, upload that data to an international database that can then be shared with the world. So the policy challenge is to get nations to agree that that data should be made freely available, because it's merely factual data of how deep the water is at a given point. And this can help us achieve the goals of Seabed 2030 and the UN decade to build an ocean model. So the technology is there. I think the major challenge we have is developing the policy acceptance to recognize that crowdsourced bathymetry is not hydrographic surveying, nor is it marine scientific research, and therefore should be treated as sui generis to share worldwide.
Thank you very much. I come to Tafsir, and I grab from something you told before, that technology is not being fooling intelligence. And so it means that anything can go wrong at any time. So my question is, how do the challenges materialize when it comes to the liability?
Thank you for that very timely and topical question. So the first question that comes to mind with reference to your question is, why do we deploy technologies? We deploy technologies, and as Stephen already mentioned, to collect data, and data forms a part of evidence-based research, and we use that evidence-based research to correct problems. So let's turn to the vessel side of things. Today we have 9,734 large vessels and 4,759 very large vessels between the age range of 20 and 25 years, which means these are the older vessels that require more maintenance than the others. So we deploy technologies to collect structural defect and deficiency related data. So what is the problem here? The problem here is that the last thing that the ship owner wants is for the data to fall into the hands of the wrong person, because like any other sector, shipping is highly competitive. It's still business, and there are unforeseen challenges and risks. So liability is intrinsically connected with safety, security, and environment, and when any of those elements are affected, then we start pointing fingers. So rules such as liability rules will have an important bearing on the product that emerges and the incentives we provide to the manufacturers and the products we get into the market. And that is why we need to regulate robotics. Robots and autonomous systems are nothing but products. They are things. There is no legal or philosophical grounds to consider them as humans or subjects in an ontological sense. Any product you take into the market, they might or might not have defects, and if there are defects, it creates liability, and that is a major challenge that emerges from these generic technologies. Thank you.
Thank you very much. Thomas, do you think that the challenges are daunting for the classification societies to turn to disruptive technologies? And do you see the need for enhanced understanding of the problems through technology? What is your view based on the classification society experience?
Yeah, let me pick up what the two colleagues here have already started to say. We have seen in the last years, especially during the COVID period, that if there is an imminent need for new technology, a lot is suddenly possible. A lot is trialed, and accepted, where before such periods, it always takes quite a long time. We have seen and experienced the technologies that are already existing can easily be applied. And to come back here to robots, drones, and also live streaming and exchange of data, everything is possible. But we also have to be in line with the existing rules and regulations. And these have been written sometimes decades ago and are very prescriptive and not really goal-based. Therefore, it is as well difficult to implement changes without changing the existing rules and regulations. And finally, it's also the mindset of the people that have to be changed. Because all involved parties have to accept that reliable technology, as Tafsir said, can achieve the same or even better results than being on-site, as other industries have already demonstrated.
Okay, yeah, thank you. Yoss, do you relate to some of the challenges that are already mentioned, and regarding the autonomous vessels, how we can overcome these challenges, maybe to have full autonomous vessels and overcome regulatory barriers?
Then, as a lot of you know, there are already many pilot projects around the world. Yeah. One of the most known is the Yara Birkeland, the first full electrical autonomous container vessel that has been christened last year, April 2022, and is doing the testing. However, there are many challenges, from all aspects, ethical, social, legal. I'm right now involved with the IMO joint working group. We are developing the code for the mass code. And I can tell you that there are a lot of discussions and a lot of work to do. The voluntary code will be for 2026, and the mandatory one will be for 2028. Then there's a lot of work in front of us. Thank you.
Thank you very much. Panos, we have heard about so many challenges with ocean observation, with robots, drones, yeah, with autonomous vessels, with the classification society. What it comes to your mind when we talk about challenges in maritime sector?
Yeah, so of course, technology and artificial intelligence is one of the pillars towards decarbonization, but we're not going to achieve that without having a new fuel, a green fuel. And what I mean by green fuel is something that when you burn it doesn't emit greenhouse gases to the atmosphere. Hydrogen doesn't emit greenhouse gases when you burn it, ammonia doesn't. However, the big problem is how do you get those fuels? Because in making hydrogen and ammonia, then you emit greenhouse gases. Right now, 95% of the hydrogen that's produced on Earth comes from natural gas, which itself is a very bad fuel, 86 times worse than CO2 when it's emitted to the atmosphere. So you take natural gas, you make hydrogen, and then hydrogen is difficult to handle. And that's why you need the other fuels that come from hydrogen, like ammonia and methanol, which are much easier to handle. But if you start with natural gas, and then you get hydrogen, you emit CO2 to get the hydrogen, and then you get ammonia, you emit more CO2, that's going to get you nowhere. So what you need is green hydrogen. Green hydrogen you get from electrolysis of water, provided that the electricity you use is from renewable sources. And that's the huge challenge. You don't have enough renewable electricity available to make all the hydrogen, to make all the ammonia and methanol, green ammonia and methanol, that you need for shipping. Yes. And not only that, even assuming that you have all this renewable electricity and you have all these green fuels, if you apply them to land, to factories, and transportation, land transportation, instead of ships, you are going to reduce your CO2 emissions 8 times more than if you apply them to ships. So the big question is, even if we had the green fuel, is anything going to be left for ships? We need new technologies, and perhaps nuclear, fourth generation can help.
Great, thank you. And John, when it comes to your mind when we talk about challenges in the maritime sector based on your field of specialization?
Well, interestingly enough, the biggest challenge that we've been seeing, which is not unique to the maritime business, but the maritime business carries all the traits, is the human factor. Mm-hmm. This is the biggest challenge, right? The fact that this is a very traditional legacy field. Things have been done a certain way for the past 30, 40, 50, 60 years. Changing is extremely, extremely difficult. there is a very, very high cost to change at the same time. The shift is not going to come over 3, 5, 10 years. There is a very high fleet utilization right now, which makes it very, very difficult to change the way that vessels are being run, because at some point in time, you need the vessel to be in a port in order to be able to make the changes. Finally, this is a high-margin business. And in a high-margin business, investing in something that is new, that is unknown, that has not been proven yet, is always a challenge, interestingly enough. So I think that the biggest challenge currently faced by technology is basically the opposite of artificial intelligence, which to a very large extent can be claimed to be real stupidity, right? Yes. And this comes from the human factor in the equation. During the first steps that I had done in the maritime business, which is 4 or 5 years ago, we kept bumping on the same issue, which was, what do people on board vessels do when an alarm goes off? How do they react? How can something be predicted? How can something be avoided? And the answer was always the same. Whenever an alarm goes off, we turn it off again and again and again. So changing that mentality, shifting into an era where technology can support, it requires the human element to accept that change.
Yes. Very valid points. I will move now to my next question, and we heard about all these challenges, but keeping technology constant, does the status quo, the current status quo, reflect a sound cooperative model? And if not, how your organization will move the agenda forward? Stephen, the floor is yours.
Okay, so from the frame of crowdsourced bathymetry and the ocean decade to create the digital model, I would say the status quo is insufficient. We have emerging technology which is useful. Right now, the GEBCO grid, the global bathymetric chart of the oceans, reflects 23.4% of the ocean bottom mapped. So we have 7 years to map 76%. And so that poses a huge challenge, but we have many ships which are transiting the ocean over routes that have never been transited before, over bodies of water that have not been mapped in any way. And so getting over that status quo of insufficiency is to maximize international cooperation. So I represent my country at the International Hydrographic Organization, which is based out of Monaco, which has always been very committed to oceanography and hydrography. And the IHO employs the crowdsourced bathymetry initiative. So out of 98 nations who are member states of the IHO, only 32 have responded to the Secretary General's request for a national response to authorize the release of crowdsourced bathymetry, or passage soundings, in their waters of national jurisdiction, which would be their internal waters, their territorial sea, and their exclusive economic zone. So that's a 33% response rate. So of those 32 nations that have responded, the United States and Papua New Guinea have agreed that any data collected in our waters of national jurisdiction or Papua New Guinea's waters of national jurisdiction would be made available with no caveats, no restrictions whatsoever. 6 other nations have authorized the release in varying degrees of caveat, some of them being minuscule and some of them being prohibitive in terms of achieving the goals to map the seabed.
Thank you. Tafsir, based on your great experience with the maritime sector and academia, do we have a cooperative model?
Well, unfortunately, we do not have that perfect desired cooperative model because let's take the example of the quadruple helix that is comprised of the government, industry, academia, and the community. So they don't speak too often, and even if they do, they don't speak the same language. Language is a barrier. They tend to operate within their own silos, and there is less transdisciplinary or interdisciplinary action and follow-ups. And also another overarching problem is looking at the discrepancies between global north and global south. It's not just about technology availability, it's also about technological know-how and, of course, capacity building for technological know-how, and that is currently missing, and there are bridges that need to be built. So enter World Maritime University, where I work, and my university is a child of the International Maritime Organization established in 1985, and what we do is we create platforms for dialogue and discussion to accommodate and facilitate all of these wonderful new innovative action items. And also we engage in regulatory development projects. Very recently we developed a regulatory blueprint on remote inspection techniques for a European Union Horizon 2020 funded project called Bug Ride 2. So we're a small fish in the ocean, but I think we have a long way to go. Thank you.
Thank you. Thomas, how is the case with the classification societies? Do we have a cooperative model there?
You know, when you look back in the history of classification societies, I like to mention that we always have adapted to the industry's changing requirements. And we started from, let's say, the era of sailing ships to all the challenges that we have nowadays, including the fuel challenges that Panos was mentioning. But as those requirements and needs become increasingly complex, as well as the speed of changes, we should take really this energy as it is the right time to transform again into the future we were just talking about. But it is really not something that we are choosing to do, it's something we have to do. And having said so, we as Classification Society, we have to become a provider of really technical, professional services to cover all these challenges. And many of them we have mentioned already before. But to do so, I'd like to pick up what John said, we have really to start a fundamental shift in our culture and to get us really thinking differently and not being afraid of trying out the new.
Okay.
Thank you.
Thank you. Yoss, till now what I have heard is that the cooperation model is insufficient. This is what I take till now. Tell me your view about it.
Yeah, I have over 40 years in the maritime industry, and what I can say is that it's always the industry that drives, new changes, yeah. And there is always a lag, from the policy government. I can speak about Canada. A lot of work has been done around mass. We have policies, we have working group, we have national research council that work on that. But I have another hat where I travel around the world and provide support and consulting. And a lot of organizations believe that putting equipment tools will make them smarter. Yes. But I always say that to really benefit from smartness, you need to be intelligent. And the intelligence, it's about the governance, the structure, the people that you have in the organization, the processes. And when you have that built and strong, this is where you can really take advantage of the technology and the mass and things like that. Thank you.
I like very much this sentence. To be smart, you have to be intelligent first. Okay? We keep this. Panos, what is your view?
Yeah, well, shipping has many and diverse stakeholders. And unfortunately, I don't think they are cooperating enough. We have ship owners, we have charterers, we have providers, we have fuel suppliers, we have ports, and many, many others. Let's take charterers, for example. Most of them, they claim they are green, but when it comes to actually doing it, maybe their money is not where their mouth is, because there are specific IMO regulations addressed to them, but their attitude is none of our business is the ship owners. We need to cooperate more, because without cooperation, we're going to get nowhere. Take fuel suppliers, for example. What is their solution to decarbonization? Their solution is, since they cannot sell fuel oil now, they want to sell you LNG and name it green. That's not going to get us anywhere. Take ports. The port inefficiencies are not addressed by IMO or anybody else. So you have ships that are speeding up to get in line, to get into the berth. They arrive at the port and then they wait for a week for the berth to be free. If you could fix those inefficiencies just from virtual arrival, you could save 30% on CO2 emissions from shipping, a huge amount. So these kinds of cooperations we have to work with. Thanks.
Thank you very much. John, could you please offer us your view on this model? If we have a sound cooperative model or not? Maybe you are more optimistic.
I think that, yeah, I think the quick answer is no, right?
Okay.
But I also think that taking a step back, there's very few industries out there where you do have a sound and working cooperative model. Actually, if pushed, I think all of us will have a hard time identifying the industries where a global cooperative model is in place and everybody's working happily towards a common goal. Now, I think within shipping, there's 2 or 3 elements that differentiate this industry versus others. One is consolidation. The number of players is not as many as in other industries. You do not have the same level of fragmentation that would require the adverse and numerous stakeholders to align in terms of what needs to happen. So that's definitely a positive. Secondly, regulation has come and is coming to make sure that the right decisions are made, question mark, by when, clearly. But the regulatory environment is there to coordinate the required moves from all the different players. Now, the third and final question is, how can we make sure that on a day-to-day basis, the sector works in a collaborative way? And I think that if we look at how things were 10 years ago versus where they are now, there has been huge positive steps that have shown that collaboration, co-development, alignment, working as part of an ecosystem is the way that the shipping industry is heading towards. I firmly believe that technology is a catalyst and it's an accelerator to that. It's not the only thing, clearly. But I feel that although all of us accept that we're not at a good state, we're in a much better state than we were only a few years ago.
Yes.
And secondly, compared to other industries, the opportunity that you have in the short term is much closer and requires potentially fewer steps.
Thank you very much. And we saw that the cooperative model is also efficient, but you came up with some strategies how we can enhance this cooperation. So taking this and John's last word, I would like to know how we can bridge the gaps to enhance blue oceanic affairs, which is also the title of our panel. So I'm looking for solutions, how we can bridge the gap. Stephen?
Thanks, Aspa. The solutions are within the grasp of extant institutions. So with regards to the IHO and the crowdsourced bathymetry initiative, the IHO firmly supports the crowdsourced bathymetry working group, which represents a gathering of both international member states, academia, and industry to try to close and bridge these gaps. And so this group meets at least once a year to devise strategies, to provide better information to the various stakeholders so that they can understand the distinction between crowdsourced bathymetry, passage sounding data as being distinct and separate from hydrographic surveying and marine scientific research. The development of inexpensive data logging technology is another positive aspect. So I don't want to come across as being a pessimist, but there are the institutional opportunities for us to dispel some perhaps myths about crowdsourced bathymetry and to achieve that goal to map the seabed by 2030. One of the other aspects of the UN challenge for the ocean decade is an equitable and sustainable marine environment. So the idea of sharing this data freely with developing states for anyone to use for a variety of purposes it gives me hope, it gives me optimism as to the ability for nations to cooperate and collaborate totally within the law of the Sea Convention, recognizing the sovereign rights of coastal states, et cetera. So I believe that we have the institutions that are available. It's just developing the will within our individual sovereign interests and to work together to be able to make that data available. Thank you.
Thank you very much. Tafsir, you told me before that the cooperative model is insufficient. Tell me now how we can bridge the gaps.
Yeah, thank you. So I'm not going to sugarcoat it. I'll be very acerbic. We must avoid fragmentation, especially at the European Union level, which is one economic and cultural area. And we must also bridge the gaps between technology and regulation. We have regulation, but the question is that fit for purpose? So if, for example, someone used Higgs boson to invent a time machine and that time machine injured a person, the judge cannot simply fold his hands and say, I can't adjudicate on this matter simply because there are no civil liability rules on Higgs particles. He will still have to adjudicate. He has to unleash the full potential of what exists. The second point to note, again, coming back to the title, Blue Oceanic Affairs, blue, is balance. And liability tends to offset that balance, and quite often I think we need to rely on other sectors to extract good practices. So if a producer is held responsible in an autonomous vehicle situation or an incident, he is responsible for all degrees of autonomy, whether it's a semi-autonomous vehicle, whether it's a full autonomous vehicle. But what he will do is that he will acquire insurance and he will distribute the costs among the parties. He will, in fact, exploit the economies of scale, and it's not the producer that actually bears the responsibility. So if there's an incident, then the producer will be held responsible, but then he's not paying from his own pocket because it's the purchaser that's actually paying for those costs. So these are good sound models. Sound models actually exist. And finally, I would have to say that what Thomas mentioned about changing mindset, connect that with what Yoss said, that autonomous vessels are not the same as remote inspection techniques. No two technologies are the same, which is absolutely correct. So I translate that as being, we need to stress to identify the profound differences that differentiate between different classes of information, and that is why we need a class by application approach. We need the right mindset. We do have certain amount of collaboration, don't get me wrong, but we are just not there yet, unfortunately. Thank you.
Okay, you end up again with the word, unfortunately. Okay. Yeah. Thomas,
yeah,
how we can bridge the gaps?
Yeah, thank you. I like to answer in a way that a people-centered and collaborative system approach is needed to scale up the ocean economy safely and sustainably. Yeah. There are great opportunities, but they should not come at the expense of human lives, as we all should be aware that the ocean is still the most dangerous place on Earth to work. Okay. And risk could increase when the blue economy scales up and too rapidly to meet the growing demands of the populations. We need to make sure that we have the right standards in place to protect these workers. Engineers should take the ocean and climate science and turn it into action so that they can play a crucial role in making the ocean industry safe and sustainable. And we need new approaches to engineering to make sure that the infrastructure being built and adapted is also future-proof. And we know that the ocean and the maritime industry is still dynamic and ever-changing, so we also have to make sure that we don't put harm elsewhere instead. And we need to build up capacities across systems, so especially in parts of the world where there is or there will be a skills gap. So we can minimize the risk by doing so. And thank you.
Thank you. Yoss? Give
Yes,
us your ideas.
I'm going to talk about Canada. Canada was and is always very concerned by environment and sustainability. It was, I think, one of the first adopter of the sustainability concept and philosophy. Greenpeace was born in Vancouver, by the way. Then there are a lot of initiatives, and we talk about this blue economy. There is a strategy in Canada about the blue economy, trying to balance, the usage of resources. And but I always say all these initiatives are very good. But and I'm going back again to Tafsir about the collaboration. And I have seen very good initiative, but they failed because of the implementation. And I've seen many around the world. The implementation is key. It needs to be planned. You need to have the actors around the table, the right actors, and to take the time to plan it. I can bring several examples, but we don't have time here. But again, implementation is the key element for success. Thank you.
Thank you. Panos, you have been to the IMO meetings so many times. You see how the cooperation works or not. So tell us.
Tafsir questioned whether the regulations we have are fit for purpose. And I don't think they are. For example, at IMO level, which is the international level, we don't have a price for carbon. We don't have a cost for carbon. And without that, you go nowhere. I mean, EEDI, EXI, and CII, and those kind of things, without having a levy, a market-based instrument, putting a cost on carbon, we should have this yesterday, but still we don't have it. So regulation is, proper regulation is the most important thing to go towards a blue environment. The EU is trying with the Green Deal and all these packages, and of course they are claiming that they are trying to push IMO to go there, but having been at IMO, I feel otherwise. The EU, for example, says, yes, we are for an international price for carbon, only as long as it is ETS. and they were the ones that stopped this discussion 10 years ago. So unfortunately, cooperation is needed, but vested interests go in the way and prevent us from having uniform and proper regulations. So I hope that changes in the future.
We hope, too. And John, tell us your views and give us solutions, how we'll bridge the gaps in the sector.
Again, I don't think I'm going to say something new, right? But at the end of the day, there's three elements, and I think that we've already touched upon most of them. So A, data. So making sure that we collect the information, making sure that we know what the numbers are at any given point in time. I think we're getting to a good point in this industry with respect to data. Secondly, democratization of that information. So making sure that there is a common place where the information is stored, where the insights are being created, and then the insights are fed back into the industry. And then the last point, which is also what Panos mentioned, I think it's 100% correct, accountability. Without accountability, all of the rest is irrelevant, right? I mean, I like, in general, I like drawing analogies, right? And if you look at the unfortunate way that, for instance, our fellow Greeks act in the way that decisions are being made. So if you look at correlations, the past 30, 40 years, every government has tried to reduce the average speed on Greek highways. So what draws the highest correlation between reducing the speed? So is it the speed limit? No. Is it the number of lives lost? No. The highest correlation between speed reduction and effect is the price of fuel. The higher the price of fuel, the slower people go. As simple as that. People do not care about losing their life. They care about having to pay more for speeding. And the same applies to this industry. There needs to be accountability in order to achieve results.
I keep this word. Accountability is a very important word. And I have taken so many points from this discussion. And first of all, we saw how technology brings a paradigm shift in the maritime sector. We talked about geospatial-intelligence and how we will be able to collect and analyze data for our oceans, how the robots will clean and maintain the ship, how the classifications with these technologies also will inspect the seas. We talked about the future of the autonomous vessels, how is the situation with the greenhouse emissions, and about artificial intelligence. And we told many times the word insufficient, the cooperative model. We encounter many challenges. When we come to ocean exploration, there are conflicts between the states because probably they don't exchange data. With the regulation of robotics, we need a top-down approach at the international level to enable us to overcome the challenges. With autonomous vessels, we still need cooperation to move the agenda forward. And with the alternative fuels and decarbonizations, as we discussed, there are still many challenges because out of the 6 alternative fuels that already have been tested for the maritime sector, one, I think you told, is the most positive with results, and this is the methanol. And the main problem that we encounter as a sector is how we will produce green fuels throughout the production cycle, from scratch to the end, and how we also overcome all these challenges with artificial intelligence that John mentioned. And I keep that, as we noted from the panelists, it's the intelligence of the people that matters. And the system is not yet fully intelligent, so we have time to reach there. And I would like to close by quoting the word of Bill Gates, that I read it a few days ago, it impressed me. So robotics and other combinations will make the world pretty fantastic compared to what is today. So staying with this positive quote, we wish that the 5th industrial revolution that is approaching fast will turn the human mind from boring and unsafe task to a more human-centric and sustainable maritime industry. So thank you all very much and for your attention. Thank you, all the panelists.
Thank you very much.